little introduction to graphing polynomials, some of the starting basics. Okay. So the first thing, let's talk about the leading term test. Leading term test. So what this does, it finds the end behavior of a polynomial. Okay, because polynomials typically, whenever we have a polynomial, we'll see this with our examples, but they're going to be things that curve like this. You probably already know something with x squared is a parabola like this, but as you increase the degree, it might have more curves. Every time it turns, it has to do with the exponent, which we'll get into. But knowing what happens at the end, like over here and over here, here and here, here and here, that is determined by whatever the leading term is. And so going back to a function being a sub n x to the n power plus more terms after that, this is the leading term. If, so there's going to be 4 situations. If n is even and a sub n is greater than 0, what happens is that it looks like this. So this little squiggly right here in the middle means that could be different terms, but it means that it is, as x goes to negative infinity, it's going up. As x goes to infinity, as x goes to infinity, and as x goes to negative infinity, then it's going up. So a little introduction to notation like that. And it could do multiple things in between. Which, going back to we know that x squared is a parabola opening up. That makes sense. It's just, it only has one change right here from decreasing to increasing. But if it's to the 4th power, to the 6th power, it could have more terms. Okay, so, and then if f is even and a sub n is less than 0, so if the leading coefficient is negative, less than 0, then we know it's going to be kind of like a parabola going down, but there could be other terms in between. Now, if n is odd and a sub n is greater than 0, now the way to kind of remember this, if you know what x cubed looks like, x cubed is like this. Here's my axis. So it starts low and then keeps increasing. So that's for anything that's odd. So that is going to be the case if the leading coefficient is greater than 0. And it could have other terms in there, but it starts down at negative infinity, goes up, does maybe some turns, and then ends up increasing. And then if n is odd and a sub n is less than 0, if it's negative, it does the opposite. It decreases, might have some turns, and then it decreases at the end as x goes to infinity. Okay. So that tells us what happens at the start and the finish of the graph of the function. Okay, so but like I said, kind of go off of, if you know x squared looks like that, x cubed looks like this, that gives you a pretty good idea. So let's also now add on the fact that we should be able to figure out the x-intercepts, which maybe you've already learned that these are called the zeros of the polynomial. The zeros of the polynomial. Okay, so the zeros of the polynomial are the same as on the graph. These are the x-intercepts. And how do you find out x-intercept? That's when y equals 0. So if you have f of x equal the polynomial, the x terms parts of the polynomial function, then plug 0 in for f of x or y, and then we solve for x, and those are going to be our x-intercepts, called our zeros. Okay. Let's jump into an example. f of x equals x to the fourth minus 10x squared plus 9. Okay, so we're going to sketch the graph of this. We're not going to find every little point, but we're going to first, let's talk about the end behavior. End behavior. So we have an even exponent, n is 4, and a sub n, which in this case is 1, is greater than 0. So that means that this is like our first situation for the ones we just defined. So we know it's going to do something like this. Decrease, change, end up increasing. Okay, so there's our end behavior. We don't know what's happening in between though, and we don't know exactly where it's laid out on my graph. Sketching a few things here. So now though, let's figure out also the zeros, the x-intercepts. So if I set the function equal to 0, 0 equals x to the fourth minus 10x squared plus 9. This is y is 0. If I find my x's, that's going to be my x-intercepts. Okay. So let's see what we can figure out. We should be able to factor this, it looks like. Because I'm seeing x squared should turn out nicely. 9 breaks down to get to 10. It looks like I could do a 9 and a 1, both minus. Now I'm going to go further. Break this down to x plus 3, x minus 3. And then let's factor x squared minus 1, break that down to x plus 1, x minus 1. So, if I set each of these equal to 0, x plus 3 equals 0, means x is going to be negative 3. X minus 3 equals 0, means x is going to equal 3. And maybe you don't need to write out this line, but subtract the 1 over, and then x minus 1 is 0, add 1 over. So I get my zeros. So my x-intercepts or my zeros, same thing, are, let's put these in order, negative 3, negative 1, 1, and 3. Okay, so I'm going to put those on the graph. So negative 3, negative 1, 1, and 3. So I know it's going to come down, and I know it's going to end going up. Now in between, what's going to happen is that it goes through, up. Actually, I should know how pretty quickly also what my y-intercept would be, right? Let's do that over the slide. Y-intercept would be when x is 0. So that would be when 0 here, I get 9. So it's actually going to go up all the way up to 9. Back down, down, up. Now to figure out what these little points in, I could, plug in. It looks like 2 and negative 2 to get it a little more accurate, but this is good for now. So let's double check this on Desmos. It's x to the fourth minus 10x squared plus 9. Okay, so there's my graph. Zoom out a little. Okay, so here's those zeros. Negative 3, negative 1, 1, and 3. End behavior like we found. We figured out 0, 9 was my y-intercept. So notice if I had plugged in 2, so actually the low point isn't exactly 2. It's not exactly symmetrical right in between. 2.236, negative 16. So we'd have to kind of figure out a bunch of points to fill that in a little better. But let's just look at what if I had thrown a negative in front, because remember the leading term test says that it would at the beginning decrease, end up increasing. But if I throw a negative in front, kind of change the whole thing, but now it's upside down.